There are two types of compounds we're going to look at a little bit later: ionic compounds and covalent compounds. Ionic compounds are formed between a metal and a nonmetal. The metal loses electrons to become positive. The nonmetal gains electrons to become negative. And there's an attraction between positive and negative to form an ionic compound. Covalent compounds are formed from the sharing of electrons, and this occurs with nonmetal atoms combining together. Oxidation states are numerical values assigned to atoms that reflect these transfer of electrons or the shifts in electron density. And so we want to determine the oxidation numbers or the charges that these atoms take on. For example, sodium chloride in the compound, sodium takes on a positive charge and chloride takes on a negative charge. The positive and negative attract to give you the ionic compound. So we need to determine how we get these charges on these ions. So there are certain rules that we're going to follow. Number one, the oxidation state of an atom uncombined with other elements is 0. So if I just have an atom of sodium and it's not combined with chloride or anything else, it doesn't have a charge, it's 0. Or if I just have hydrogen by itself, which even though it's diatomic, it's still by itself, charge is 0. Number two, the sum of the oxidation states of all atoms in the formula is 0 because atoms are neutral. For an ion, this total is equal to the charge on the ion. The group 1A elements always have an oxidation state of +1, and the group 2A elements, the alkaline earth elements, always have an oxidation state of +2. Number 4, aluminum is +3 in every one of its compounds. Number 5, hydrogen is +1 unless it's with a metal. If hydrogen is combined with a metal, hydrogen takes on a -1 oxidation state. Number 6, fluorine is always -1 in every one of its compounds. Number 7, oxygen exhibits the -2 oxidation state in all of its compounds. There are some exceptions here, but 99.9% of the time, oxygen is -2. Number 8, in binary compounds with metals, elements in group 7A are -1, elements in group 6A are -2, and elements in group 5A are -3. And then number 9, we can determine the oxidation state of an element involving several combined elements by assigning oxidation states to every element and then applying the rule number 2. So let's look at a couple examples. Determine the oxidation state of nitrogen in NO2. Well, if you go back to rule number 7, oxygen 99.9% of the time is -2 charge. So I know oxygen is -2. So I'm going to do a little bit of algebra here. I'm going to take nitrogen plus 2 oxygen, and I know the sum of charges is 0 because this is a neutral compound. So plug in what I know. I know that oxygen is a -2. So that means nitrogen, when I solve this, has to be a +4 charge. Now if you go back to the chart rule and you look where nitrogen's at, it's in group 5A, you would expect a +5 or a -3. But it's not, it's +4. We don't follow the chart rule anymore because the chart rule does not apply 100% of the time. So we need to go back to these 9 rules and follow those to determine the charges. Determine the oxidation states of chromium and sulfur in Cr2S3. You go back up to the rules. This is a binary compound, so look at rule number 8. Since sulfur is in group 6A, it's combined with a metal, sulfur has a charge of -2. That's following rule number 8. So let's set up our equation here. We're going to take 2 chromium plus 3 sulfur, and the sum of charges, it's a neutral compound, is 0 again. So I know sulfur, plug in its value here, -2, set it equal to 0. So I have 2 CRs minus 6 equals 0. Simplify this. So each chromium has a charge of +3. So chromium's +3, sulfur is -2.